Hello, Intro to Algebra students. We're going to take a look at Chapter 4, Lesson 1, and that's on page 267 of your textbook. So you want to have page 267 open and ready to go before you take your notes. So this chapter is all about modeling relationships between quantities, and we're going to be looking at our linear equations and relationships that we learned about in Chapter 2 and Chapter 3, and kind of looking at that in context of real-world situations. So again, we're on page 267, and we're looking at the real-world link. We have this problem about space, so we read that problem. To achieve orbit, the space shuttle must travel at a rate of about 5 miles per second, and the table shows the total distance d that the craft covers in certain periods of time t. And then we have that information over in the chart. And we're asked to write an algebraic expression for the distance in miles for any number of seconds t. So we're looking at, like, how do we find our distance based on the seconds? So if we're looking at that, we want to compare our y over x, and you're looking for that unit rate, which you can see is 5/1. We would check it with a couple of others, and you can see that 10/2 would reduce to 5 or 5/1, and 15/3 would also reduce to 5 or 5/1. So that is that unit rate or slope. And so in order to get from the time to the distance, we look at what's happening. And we are, hopefully you can spot that we are multiplying there, and that we are multiplying by 5. So the expression is that you take 5 times the number of seconds to get the distance. Now you're asked in number 2 to put that into words, and that is what we just said there. So you're looking at that relationship, and the distance is 5 times the number of seconds. Then we're asked to graph the ordered pairs and describe the shape of the graph. So if we look at our chart, you should see that your x-axis is your time in seconds. So we want to put that in for our label. And our y value, our y-axis, is going to be our distance. And we're measuring that in miles. And then we're just going to take a moment and graph each ordered pair. So our first ordered pair is 1, 5. So remember, you're going across and then up. And then our second ordered pair is 2, 10. And you should be adding these in on your textbook as well. And then 3, 15. 420, and 525. So then you're asked to describe the shape of the graph. So hopefully you can take a look at that graph and see, okay, what shape is that graph taking? And then we would want to summarize that in our text. And because that graph forms a line, we say that that graph is linear. So the next page we're looking at is page 268, the tables, graphs, and equations. We want to recall that any equation is a mathematical sentence stating that two quantities are equal And a linear equation is an equation with a graph that is a straight line. So some equations contain more than one variable. We look at our first example, and the table shows the number of liters in quarts of liquid. So we're asked to write an equation to find the number of liters in any number of quarts, describe the relationship in words. And the rate of change is a rate that describes how one quantity changes in relation to another quantity, and the rate of change of quarts to liters. And you can see here they're doing the steps of taking y minus y over x minus x, and that should look familiar to you because, of course, the rate of change is the same as slope. And they're looking at that comparison. Now, because the calculations show that the rate of change or slope is 0.095, they're writing the equation as L is equal to 0.95 Q. Now, that is the same thing as the y equals 0.95x. We're just using different variables for the x and the y. So we're just saying, okay, the quarts are your x value, and the liters are your y value, so that it applies in the context of the story. So in step 2, we're asked to use the equation to solve a problem. So about how many liters are in 8 quarts. So you can see that they have taken the equation, and we want to apply that to a new situation for 8 quarts. And so you're just taking that 8 and plugging it in as your input for 8 quarts for your x value or your q value in this case, and then they multiply. And then we get our result that there are about 7.6 liters in 8 quarts. So you can see that you're going to be asked to write an equation based on the information and then use that equation to find something that we haven't been given. So in the Got It problem, we're asked to kind of apply these things from the examples. So we've gotten a chart, we've got the number of tickets and the total cost. And for part A, we're asked to write an equation to find the total cost of any number of tickets and describe the relationship in words. So you want to look at, okay, what is the rate of change or what is the slope? And so you want to take a y minus y, x minus x. You don't have to use the first two. You can use any pairs there, but you do want to do that. So take a moment and put that in. So hopefully you got a slope of 4.5. And so we can apply that in an equation. And then we're asked to use that equation to find the cost of 15 tickets. So I'd like you to take that and plug it in and find the cost of 15 tickets. So hopefully you got $67.50 for the cost of 15 tickets. And we're going to take a look at some more examples tomorrow with the next part. If you miss any of the notes, please go back and review. You can't skip through the video when you first watch it, but you can go back and rewatch. And when you're rewatching, you can skip through the parts that you need. All right. And have a good day.